Okay, we're ready now for lesson 9.4, and this is a very important lesson in the area of trigonometry because the major focus of this lesson will be on this unit circle concept. Your ability to understand the unit circle is, in my opinion, maybe the most excuse me, useful of all concepts in the area of trig. So if you're headed to pre-calculus or algebra 3, you should really pay close attention to how to construct the unit circle, have a good understanding of it, because it is such a helpful tool in this area of trigonometry. So the bulk of this lesson, we're going to start off with how do you construct your own. You are going to have to do that yourself, and I'm going to walk you through that. And then we're going to look at this idea of trig functions being periodic and talk about some other necessary things in this area of trig. So let's just get to the unit circles. I provided you a blank just like this. Hopefully you've either printed it out or you've made your own copy of it. It's very important that you have this before you go any further. So if you don't, you want to pause the video and go ahead and either print this out or construct it yourself with these blanks, and make sure you make it big enough because we're going to be doing quite a bit of writing on this. And so hopefully now you're ready. And let me just, if we were in a traditional classroom setting, we would talk a little bit more of the proof of where we're getting these numbers that we're about to write. Since we're in this distance learning setting, we're just going to cut to the chase, and I'm going to show you a little trick, I guess you could call it, a little shortcut that I learned many, many years ago, and it's very useful when you're constructing your own unit circle. All right, so here's the thing about the unit circle. The radius of the unit circle, I've mentioned this in previous lessons, the radius is 1 all the way around. That's an important note to mention right off the bat. So the radius of the traditional, when you hear about the unit circle, it's always true that the radius is 1. Okay, so that means these ordered pairs look like this. We'll just start here at this angle. Okay, this is both the initial and the terminal side for this angle right here. So this would be 0 degrees. Let me get my pen working. Okay, this would be 0 degrees if we hadn't started yet, or 0 pi. We'll put degrees here and then radians here. And then if we did go all the way around, of course, that would be 360 degrees and 2 pi. Okay, and the ordered pair for this point right here where the side intersects the circle, of course, that would be the point 1, 0. Okay, now for this angle here, this is the 30 degree. Okay, so just think about your special right triangles in this first quadrant. We're going to be identifying those famous angles that we learned when we learned the special right triangle, the 30, the 45, and the 60. Okay, so we can just go ahead and fill in these blanks. So this is the 30 degree, this is the 45, this is the 60 degree. Obviously, when we get up to here, this is 90 degrees. All right, so remember what these are in radians. All right, 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3, and 90 is pi over 2. All right, and now let's talk about the ordered pairs. Well, remember, we talked about this in a previous lesson. When you're talking about these points where the terminal side intersects the circle, the x-coordinate relates to cosine. Okay, very important that we remember x is cosine, and y correlates to sine. And while we're talking about it, we talked about tangent as being sine over cosine, or y over x. All right, so the same thing is true here. when we go down these ordered pairs, the x is going to be cosine and the y will be sine for each one of these angles. Well, here's where the little trick is going to come into play. All right. So what you can do, starting up here at the top, here's how you can remember the trick. We're going to make fractions. Now these are blanks, so I'm going to make little signs to represent fractions. Okay. And I'm going to put radicals on the tops. And on the bottom, I'm going to put 2. I know it's getting a little bit messy because I'm writing on top of this document. So far all I've done is I've made fractions. Okay. And the top of every fraction has a radical and the bottom of every fraction has a 2. Okay. So that kind of sets us up, and here's how we get the official ordered pairs that represent these angles. Start at the top, and you're going to do 1, 2, 3. Okay, 1, 2, 3, and now going the other direction, 1, 2, 3. And that gives you, now we did radicals, the way I learned this years and years ago, we start with radicals just to stay consistent. Radicals on the tops, 2s on every bottom, and then you count 1, 2, 3, 1, 2, 3. Okay, but really, think about what is the square root of 1? Well, that's just 1. So you technically don't have to have the radical for 1, but just for consistency's sake, showing how you set it up, that's just the way this is explained. Sorry, I'm having trouble with my little pen here. Okay, so now back to our little discussion here. If you know the unit circle, you know that, you may already know this from your special right triangle memorization, but cosine 60 degrees is 1/2 because that's the x-coordinate for the 60-degree angle. Sine 60 degrees is the square root of 3/2. Okay. Cosine 45 degrees, you just look at the x-coordinate of the 45-degree angle and you got it. It's √2/2. Sine 45 degrees, also √2/2 because sine corresponds to the y-coordinate. All right, cosine 30 degrees is √3/2. That's the x-coordinate for the 30-degree angle where it hits the unit circle. Okay, sine 30 degrees is 1/2 because that's the y-coordinate. So you see how knowing this unit circle really gives you, for the famous, the popular angles and the ones that are coterminal for these, the unit circle is huge. It's a great tool. And one of the things that you'll be asked to do in future math classes is to reproduce it and be able to use it. And I hope you take that to heart as you cover this lesson. All right, so let's go ahead and fill in our ordered pair here. This is the point 0, 1. So remember, for the 90-degree angle, if you want cosine 90 degrees, you just look at the x-coordinate, and that's 0. Sine 90 degrees would be the y-coordinate, that's 1. And tangent 90 degrees, we talked about this previously, would actually be undefined because you would be doing 1 divided by 0. Okay, so if the bottom line of this is if you understand the first quadrant and doing that little trick that I showed you, 2's on all the bottoms, radicals on every top, and start here and go 1, 2, 3, and then go 1, 2, 3. You've got quadrant 1, and if you know quadrant 1, it's the same ordered pairs that will be used as we go around the unit circle. We're just going to change the signs, S-I-G-N-S, accordingly to represent the particular quadrants. Okay, so if you understand quadrant 1, the rest of this is going to be pretty easy, and then I'll show you a little trick to remember when it comes to radians. Some people struggle with the radian measures for these angles. All right, so let's just keep on going. We're now working in quadrant 2, so this angle right here would be 120. Okay, we went 90 plus 30. Now we went 90 plus 45, that's 135. Then we went 90 plus another 60, and that's 150. And then halfway around, of course, is 180. Okay, now let's think about radian measures. All right, so you went basically to 120. If you remember, you could use your conversion method. Eventually, hopefully this will be memorized. But remember how you convert from degrees to radians? You multiply by this conversion factor and just think 120 over 180 reduces to 2/3. So this would be 2 pi over 3. This would be 3 pi over 4. Okay, so you can also think of it breaking it up into fourths. Here's 1/4, 2/4, 3/4. Okay, and now we're breaking it up into sixths, 1/6, 2/6, 3/6, 4/6, and this would be 5/6. So this would be 5 pi over 6. Or you could use your little conversion method. All right, now let's look at the ordered pairs. Well, for this angle 120, it's just like the 60 degree, but we have to remember that in quadrant 2, cosine is negative. So this ordered pair is going to be negative 1/2, and sine is positive, positive square root of 3 over 2. For the 135, it's going to be the same as the 45, but again, cosine is negative and sine is positive. Cosine relates to the x-coordinate and sine relates to the y. For this 150 degree, it matches up to the 30 degree, but again, instead of positive root 3 over 2, it's going to be negative, and then sine is still positive. Okay, so you see how that works? Okay, so for the 180 degree, we didn't write down the radians for this. That's pi radians, and the ordered pair, of course, is -1, 0. So that means cosine 180 degrees is -1, sine 180 degrees is 0, and tangent for 180 degrees is actually 0, because 0 divided by -1 is 0. Okay, so we're just going to keep on following the same routine. So let's think about the degrees. So here we are, we were at 180, so we went 30 more, that's 210. And then here's another 15, or you could think 180 plus 45, that's 225. 180 plus 60 is 240. And then this is 270. Whoop. Wrote it in the radian blank. Okay, so let me show you a trick on how to get the radians. If you're struggling a little bit, hopefully up to this point you understand pretty well. And then from here, here's a little trick. If you just go, I'm here at this 210 degree angle, and just go to the other end of that angle and look at the radian degrees. Do you see how that's pi over 6? Well, if you want the radian for the other end of that line, okay, I'll just go, here's one end. If you just take the denominator, 6, and then add whatever's in front of pi, 1, so it's 7 pi over 6. So the denominators will always match when you look at from one end of that line to the other. Okay, so let's try another one. For this 225 degree angle, I'm going to go up here, and to get the radians, I'm going to do 4 plus 1, which is 5, over 4. Okay, pretty easy. Here it's 3 plus 1, 4 pi over 3. Okay, so we got the degrees, we got the radians. Now let's look at the ordered pair. So once again, just go to the other end of this line and use the same numbers, the same coordinates, but we got to change the signs because in quadrant 3, both of these are negative. So this is negative square root of 3 over 2, and negative 1/2. All right, at the other end of this line, I'm going to use the same ordered pairs, root 2 over 2, but they're both negative. And same thing here. I'm going to go to the end of this line, the quadrant 1 end. I'm going to use those same coordinates, but I'm going to make them both negative. X is negative 1/2, y is negative root 3 over 2. And I drop below here, so obviously this is the point 0, negative 1. So for 270 degrees, cosine is 0, sine is negative 1, and tangent is undefined. All right, now let's finish it off. So we got to do our radians, 3 pi over 2 radians for 270 degrees. All right, let's finish it off. So we're at 270, we went another 30, so that's 300 degrees. This is 315, and this is 330. We just went 15 degrees between each, just like we did up here. Notice how we went 15 degrees, 30, 45, 60, 15 degrees between these. All right, now let's do the radians. So once again, just go to the other end, go to the quadrant 2 side, and the radians was measured at 2 pi over 3, so just do 3 plus 2, that's 5, 5 pi over 3. Okay, 4 plus 3 is 7, so this is 7 pi over 4, and 6 plus 5 is 11, so that's 11 pi over 6. All right, now let's get our ordered pairs. So let's see, at the 2 pi over 3 end of this, it was negative 1/2 root 3 over 2. But in quadrant 4, cosine will be positive, so it makes positive 1/2, and that'll be negative root 3 over 2. Okay, and for 7 pi over 4, again, cosine is positive, sine is negative. And for 11 pi over 6, or 330 degrees, cosine is positive, sine is negative. All right, and so we've made it all the way around. The only other thing that I want you to be able to do is when you get this yourself, is I want you to be able to fill in what is positive and what is negative within each quadrant. And I didn't leave a whole lot of room for that, but I'll walk you through how that's going to go. So in quadrant 1, I'm okay with you just saying all. Now what this is asking for is cosine, sine, tangent, cosecant, secant, cotangent. Everything in quadrant 1 is positive. Okay, but when you get to quadrant 2, what's positive? Well, sine is positive, and its reciprocal, which is cosecant, is positive. And then everything else is negative, but don't say everything else. I want you to list it out. So cosine, secant, tangent, cotangent. Okay, that takes care of quadrant 2. For quadrant 3, what's positive? Well, tangent is positive because of y divided by x. Negative divided by negative is positive. And always remember that the reciprocal of a trig function is always the same sign. So tangent is positive, so is cotangent. That means everything else is going to be negative. Cosine, sine, secant, cosecant. All right, now we're over here in quadrant 4. What's positive? Cosine is positive, and so that means secant is positive. Everything else is negative. Sine, cosecant, tangent, cotangent. Okay, so next week, I'm going to give you a heads up. I'll give you some more information, but you are going to be graded on your ability to fill this out. Okay, and it's really, again, it's not tough. If you nail down quadrant 1, everything else follows suit if you just remember, as far as the ordered pairs, how the signs, S-I-G-N-S, change within each quadrant. And then I showed you the little trick about changing to radians. Hopefully that helps. So make sure you're good with this because it's going to be so helpful. So what I want you to do, before we move on, I'm going to give you a little assignment here. I want to see what you can come up with. And I want you to write your answer here in the top right-handed corner of your paper if you printed this out, or on your notebook paper if you sketched this out. Okay, I'm going to give you 3, and you can just write your answers one on top of the other. Just write the answer, okay? And you can pause the video and take a look. So I want you to give me, just write down, first of all, what is cosine 210 degrees? Okay, write that down. What is sine 7 pi over 4? Write that down. And then what is tangent 120 degrees? Okay, so I'll say that one more time, then you can pause the video, write your answers, and then I'll just read off what you should have put. Cosine 210, sine 7 pi over 4, and tangent 120. Okay, take a minute and write down your answers. Okay, so hopefully your top answer is negative square root of 3 over 2. That's the x-coordinate for the 210 degree angle, looking at the unit circle. Your second answer should have been negative square root of 2 over 2. That's the y-coordinate for the 7 pi over 4 angle. And then for tangent 120 degrees, hopefully you came up with negative square root of 3. That's y over x, the y-coordinate divided by the x-coordinate for the 120 degree angle. Okay, so hopefully you were successful in writing those down. And now let's go and let's finish up our notes. Get you ready for some homework problems that you're going to be doing tomorrow. The terminal side of an angle theta in standard position intersects the unit circle at each point. Okay, so they're identifying ordered pairs where the terminal side of theta hits the unit circle, and they want you to find cosine and sine. It doesn't really get any easier than this. This is one of the easiest assignments you will ever have. Remember, cosine refers to the x-coordinate of the ordered pair where the terminal side hits the unit circle, and sine references the y-coordinate. So literally, if you're looking at a point where a terminal side hits the unit circle, that's important, it has to be the unit circle, cosine is going to be the x-coordinate, and sine is going to be the y-coordinate. So that would be my answer for letter A. For letter B, same thing. Cosine is the x-coordinate, sine is the y-coordinate. And that's all you have to do for problems like this. Okay? Now, let's talk about this idea of a cycle and a period. I'm going to give you some definitions, and then we're going to look at how that relates to these graphs. You'll be doing some problems like this. Also, really pretty easy problems. Well, first of all, let's get some definitions. A cycle, think about that as a complete pattern. When we have finished a pattern within the graph, and we'll take a look at that in just a minute. But for now, just throwing some terms at you, one complete pattern represents a cycle. And so from there, we know that a period is the horizontal, that's side to side, left to right, the horizontal length of a cycle. So if you understand what a cycle is, then that helps you understand how to come up with the period. Okay, so let me show you how this works. Here is a particular graph, and it's the repetition of a particular pattern. Okay, so I think probably the easiest way to do this is just to start here at what we would call the origin, here on the intersection of the XY axis. And let's just see how this goes. If you notice, it goes up, and then now I'm back to where I started. Okay, so I started here, and after doing this little pattern, I'm back to here. So this represents a cycle. This is the pattern that's being repeated over and over again. So all you have to do is come up with the period, and the period is the length of that cycle or that pattern. And in this case, it's just 4. We don't know what that unit is, and it's okay. All you have to do is say that the answer is 4. Okay. The one thing to be careful about is do pay attention to how the x-axis is divided up in terms of units. That's a little bit tricky sometimes. So just pay close attention. Don't just assume it's always going to be in ones. Okay. Let's try this one. And some of these graphs are a little bit, the printing is off just a little bit, but you can assume that I'm passing through it. It looks like I'm a little bit to the right of the origin, but it actually passes through the origin. So I'm going to treat that. I like to start at what I call 0, 0. And then let's just see how long it takes to come back to this. So I go up, I go down, and then I'm back to the original starting point. Okay, so this is my pattern. It's an up and a down and then start again. And then just for color coding sake, you can see how that's really the same pattern that is being repeated over and over again. Okay, so there it is again. So here it is in red, and then here it is in green. That represents the cycle. Well, how long is that cycle? Well, once again, it doesn't always happen this way, but once again, that's a length, horizontal length of 4 units. Okay. All right, let's take a look at another one. So once again, they're not trying to be tricky here. This corner should be right there. This whole graph should be shifted just a smidge to the right. So they're not trying to, you won't have to worry about fractions or anything like that in these answers. Okay, so let's just see if we can color the cycle. What is this pattern? So it goes to the right, it goes up, it goes again to the right, it comes down, and from there, it's going to just keep repeating itself. Okay, so can you see I'm back to the starting point, and then it just does this again, and it's just going to keep doing this over and over again. Okay, so we've identified the cycle. Now, how long is it? So here again, you really need to be careful because this is really divided up into twos. So 2, 4, 6, 8, 10. All right, so again, you don't have to worry about fractions with these answers. So just assume that that's hitting halfway between 4 and 6. So my answer here would just be 5. The actual cycle is 5 units long. It extends from here to here. All right, so once again, I'm starting at, where I am on the y-axis. It really doesn't matter where you start as long as you can identify where the pattern starts and where it ends, and you can count how long it is. So, oh, sorry about that. Let's just say you did want to start here, just to be consistent. And let's see, the pattern goes down, it bounces back up, and then just pay attention to where you're back to your original starting point. And that looks like right there. And so to get the period, we need to count how long that was, and that's 8 units. Okay, easy enough. You'll be doing a few of those tomorrow. Now we're back to some problems like this where we have to rely on our unit circle knowledge. So I just went ahead and put one on this slide. You can use that same unit circle that we created at the beginning of this lesson. You don't have to create one for each of these, just one unit circle will do for all. So let's see if we can come up with some answers. First of all, we want to know what is cosine 480. Well, remember, cosine or 480 degrees is coterminal. Remember that word coterminal from our previous lesson. It's coterminal to 120 degrees. If I'm at 120 and I go all the way around 360 degrees, I'm at 480. So to get my answer, knowing your understanding this idea of coterminal is really helpful. I can really just think about cosine 120. And for the 120 degree angle, cosine will be the x-coordinate of that point. So my answer for letter A would be -1/2. All right, easy enough. Okay, so let's take a look at letter B. Okay, this angle is in radians. Sometimes it's helpful to make this a little more sensible to change this into a mixed number. So 11 pi over 4 would be the same thing as 2 3/4 pi. Okay, well remember 2 pi is all the way around. So really we're talking about an angle that would be coterminal with 3 pi over 4 or 3/4 pi. Okay, so all I have to do is go to 3/4 pi. You could either think of that as coterminal or it's also a reference angle at 3/4 pi, and we're looking at the x coordinate for that point, and that would be negative square root of 2 over 2. Okay, well, let's take a look at sine negative 3/4. All right, so here's the thing about the unit circle. When we construct it, we always construct it going in a positive direction. But sometimes in cases like this, we have to start here and go in a negative direction. Okay, so I'm going to go 3/4 pi, but in a negative direction. So let me just illustrate what that looks like. This would be negative 3/4 pi. I'll be stopping right here. And so I just look at, I know it says 5 pi over 4, but that's because when we typically construct, we always do it in a positive direction. So you'll have to rethink when you go in a negative direction. Don't be confused. I don't want you to think you're going to go all the way maybe up here where it says 3 pi over 4. You're literally going to go in a negative direction, 3 pi over 4. And then sine means the y coordinate. So negative root 2 over 2 is my answer for letter C. All right. And finally, sine 690 degrees. Okay, so let's think about what would be coterminal to 690. Well, that's 360 all the way around once, plus another 330 is 690. So the angle that's coterminal with 690 degrees would be this 330 degree. Okay, all the way around 360 plus another 330. And sine, again, refers to the y coordinate of that ordered pair. And so my answer would be negative 1/2. Okay, so again, this unit circle concept is big. It's huge, not just for Algebra 2, but for what you're going to study going forward. So take the time, let this sink in, construct it, make sure you understand how to use it. We can use it really to find angles, measurements, trig functions for just about any angle measurement you can think of. Very helpful. And I believe that's it. That's all for our notes, and you'll be working on the assignment tomorrow. But if you have any questions, let me know.